Okay, this lesson is lesson 85, and we're going to talk about the Pythagorean theorem, and we're going to solve triangles using it. So the Pythagorean theorem, you are working with a right triangle, and then we call the short sides legs, and then the hypotenuse is always across from the right angle. So we have a right, if we have a triangle, if a triangle is a right triangle with two sides A and B and the hypotenuse C, then the following statement is true. So you've dealt with Pythagorean theorem before. A squared plus B squared equals C squared. These are your two shorter sides. C will always be your longest side, and it's always across from the right angle. So if we look at a picture, A and B are shorter sides. C, in order to tell it's a hypotenuse, always directly across from that right angle every single time. So we're going to actually use the Pythagorean theorem to solve some triangles. Here's our triangle. We have A and we have B, so we need to plug those in. 6 squared plus 8 squared equals C squared. We need to actually square those, so 36 plus 64 equals C squared. Add those together, you get 100. We don't want C squared, though. Remember, to undo the squared term, you have to take the square root of both sides. So when we take the square root, we get C equals 10. So our hypotenuse is 10 units. Here's another problem. This time we have our hypotenuse and we're missing another leg. So we're going to plug in 4 squared plus x squared equals 7 squared. We're still going to square our two constants. So we have 16 plus x squared equals 49. Now this becomes a regular algebra equation. We need to move this 16 to the other side by subtracting it. So we get x squared equals 33. Take the square root to get rid of that squared. X equals the square root of 33. Generally, I will want you to keep it as a square root because that is exact. If you rounded it to a decimal, it'd be about 5.7, but I want you to get in the habit of just doing square root of 33. Okay. Another example, we're going to solve for K. Let's see, there it is. Sorry. Okay, solve for K. So we're still missing a side length. So we have 5 squared plus k squared equals a square root of 61 squared. Well, that's 25. Remember, a square root squared cancels it off. Square and square root cancel each other, so you're left with 61. Subtract 25. We get k squared equals 36. Last step is to square root. Well, square root of 36 is 6. So our k value, our leg, would be 6 units long. I want you guys to go ahead and use the Pythagorean theorem to find m. So set up your equation and solve for m. Okay, since we know the Pythagorean theorem now, we're going to look at something called a Pythagorean triple. So triple obviously means 3. Pythagorean triple means we have 3 numbers that are whole numbers, so they don't have any decimals, they're not square roots, and they represent a right triangle. Well, if they represent a right triangle, that means that they fit the Pythagorean theorem. So we're going to say, or I'm going to give you some common Pythagorean triples. 3, 4, and 5. This would be a leg, and the hypotenuse. Those will always create a right triangle, along with 5, 12, and 13. So if you're asked for a Pythagorean triple, these are 2 very common triples. Now I'm going to give you a triple, and we have to decide, is it a Pythagorean triple? 9, 40, and 41. Well, to test whether it's a right triangle, remember we have the Pythagorean theorem that we can plug things into. So imagine this as A, B, and C. Remember, your C, or your hypotenuse, has to be the longest side. So we would have 9 squared plus 40 squared. We're wondering, does it equal 41 squared? Well, that'd be 81, 1600, and 41 squared is 1681. If you combine those, add them together, you do get that they are equivalent. So yes, it is a Pythagorean triple. Last thing I want you guys to decide, is 8, 10, and 12 a Pythagorean triple?